Okay, so here's our first example with the Newton's law of cooling. So you can watch the previous video. I just kind of talked about the Newton's law of cooling formula and what all the variables mean. So now we're going to apply it to this problem with these numbers. Pizza is removed from an oven that has a temperature of 450 degrees. So basically the pizza is 450, that's the initial temperature when it comes out. It's left sitting in a room that has a temperature of 70 degrees. Then it says after 5 minutes the temperature of the pizza is 300. So the question asks, what's the temperature of the pizza after 20 minutes? Before we do anything, we have to figure out what the actual formula is going to be, and they give us enough information to provide that. So here is, to recall from the previous video, this is your Newton's law of cooling formula right here. What we need to do on that is we need to put in the given information. So let's look at what's given. Pizza removed from the oven has initial temperature of 450. The 450, that is your mu sub 0. That's your original temperature there. That's what's going to go in here. The surrounding temperature is 70. That's your big T that you have there. That's the two pieces of information they give you. So, and then this is mu sub 0. This is T. And then it says 5 minutes. 5 minutes is going to be your time. So this would be your T right there. So I'll go ahead and I'll show this. This is your T. And then 300, that's your temperature after 5 minutes. So this is mu of T, or U of T we have here. This is the information that's provided. So this is all the initial information that's provided for us in the question itself. So let's put the information in. So that U of T is 300, so we're going to put 300 in here. Big T is 70. 70 plus, we said that the mu sub 0, that's this one right here, the 450. So you put 450 in this one. So 450 you get minus your 70 again. So again, you have two big T's here, so 70 goes in twice. Then you have E, the K is what we're trying to solve for. Your time is your small t, that's 5 minutes. So now I have everything all put into this. We're going to now simplify this, and we want to solve for K, and then we're going to get our growth formula. So we have to get the growth formula first before we can even answer part A. Okay, so what we're going to do here first is we're going to add up what's inside the parentheses. Now, be careful you don't accidentally take 70 plus 450. You're not allowed to do that because all this inside the parentheses is being multiplied by E. So you can't bring that inside because you have to do the parenthesis part first with order of operations. We're going to do this part first. 450 minus 70 is 380. So we have 380 e to the 5k. You can't add these numbers together either. You can't take 70 plus 370. These are not like terms because this one's connected to the e. This one doesn't have an e, so you can't combine that together. But what you can do is you can subtract 70 from both sides. So let's do that first. Subtract 70, and we're going to get 230 equals 380 e to the 5k. So here is, this right here is what we get when we subtract 70 from both sides. We want to solve for k, so we're going to come up here, 230 equals 380 e to the 5k. Now we want to divide both sides by 380 because we want to get the e value by itself. 230 over 380, we get 0.060523 with some more decimals after it. That's going to equal e to the 5k. We want to take the natural log of both sides, so we're going to do natural log of this, 0.60526 and so forth. When we take ln of this side, automatically the e is going to cancel and you get 5k there. So now you're going to divide both sides by 5, and when you do that, you're going to get the k value, which is negative 1004. This is your k value that you get. So after going through all that, we need to now form the exact formula that we're going to use to answer part A. We're going to come back to, here's the original formula, that's the one that we have there. And now, I'm going to put in the given information that we had before. So what that'll look like is you'll have u of t right here. We have that. And then this is all the same. I'm going to leave the k value I now know because I solved for it here, negative 0.1004, and then I have time. So everything else I'm going to erase, so hopefully you got all that down. Otherwise you can pause it and rewind the video. But I just want to go ahead and get to this one right here. This is going to be the exact formula that we're going to use to answer this question. That's the K value we found by going through all that work, and we get this. And we can actually simplify that down. That's going to give us 70 plus 380 e to the negative 0.1004t. So now we have our exact formula that we're going to use here. What's the temperature of the pizza after 20 minutes? Since we have our model that's created now, we're just going to put 20 in for time. So u of 20 will equal 70 plus 380 e to the negative 0.1004. And that's going to be times 20. That's our value for t. So we have 20 that's going to go inside there. We want to multiply the exponent part out. So again, these are not like terms. You can't take 70 plus 380 because again, that's connected to the e there. U of 20 is going to equal 70 plus 380 e. If I multiply that together, you get negative 2.008. That's what you would get for the exponent when you multiply that by 20. You want to put this part into the calculator. What you want to do is you can either put all that into your calculator at once, or if you have a calculator where you have to do it kind of step by step, I would do this part first. The button, your LN button, what's over that would be your E caret. You would put that in first and get an answer. Then you'd hit times 380, and then finally you would add 70. You would kind of do it in that order. If you do all that, then what you'll get is approximately equal to 121 degrees Fahrenheit. So that means that after 20 minutes it drops to 121. So that makes sense because originally it was at 450. After 5 minutes it went down to 300. So 20 minutes is a longer time. So that's why it does go down to 120. So that would be something more that you could eat by letting it cool down to about that temperature. And so that would answer part A. So now we're going to go on and look at part B. Okay, part B. Part B says, when will the temperature of the pizza be 140 degrees? So we want to find out how long or what time does it take in order for it to cool down to 140. Here is our same formula that we used before in the previous example. So this is our formula that we came up with, or the one that we derived. We're going to use it for this particular problem. So if the temperature is cooled down to 140, that's actually what goes in after the equal sign here. So that's going to go in for u of t. That's 140. And then I have everything else, 70 plus 380 e to negative 0.1004t. So everything else is going to be the same. We're just putting in 140 in for the u of t. Now what we want to do is we want to solve this for t. So the first thing we need to do is subtract 70 from both sides. So if I subtract 70 from both sides here, I will get a 70. So 70 equals 380 e to negative 0.1004t. Okay, next we want to get e by itself, so we want to divide both sides by 380. So we're dividing both sides by 380. 70 divided by 380 doesn't go evenly. We get a decimal 0.1842105 with some more decimals you'll have after it. So that's going to keep continuing on there. That's going to equal e to the negative 0.1004t. You want to apply the natural log to both sides. You want to do that so that way you can cancel out the e that's here. So I have 0.1824 with some more decimals is going to equal, when I take ln of both sides, the natural log will get rid of the e here, so then we get this. You don't want to round this number here. I just use 4 places here, but really that number keeps going on. When you put that in your calculator, keep the whole entire decimal in your calculator. Then you'll hit the ln button with that whole number, and then divide by 0.1004. So if you round this too early, you're not going to get the correct answer. So you want to make sure that you use all your decimal places for this. And particularly if you're doing problems online, homework problems online, you probably want to make sure that this number is accurate and not rounded to 4 places either. So again, just keep in mind, if you're doing problems online for homework, some of those homework grading programs might be a little bit picky on that. So if you're not getting the correct answer, that means maybe you don't have the right decimal places out on this one. But in this case, we would divide both sides by negative 0.1004 on both sides. 1004, and then you would get your value for t. So approximately, you're going to get 17 minutes. Approximately is what you're going to get for this one. So that means that makes some sense, because at 20 minutes, it dropped down to lower temperature because what we had in the previous part. We had originally what's the temperature going to be after basically after 20 minutes, and that temperature was cooler than this. We had 121 we got for the previous part, so it means it took 20 minutes for it to cool down to 121. So if we're only at 17 minutes, that makes sense that it would only have cooled down to 140. It wouldn't have cooled down as much because we have less time.